Quantum physics, or quantum mechanics, is the study of particles at subatomic scales, for example, photons or electrons. The name comes from the concept that physical quantities can only change in quanta, which are small packets of energy or light. To delve deeper into the study of quantum physics, we must first observe the nature of light. The first question we will encounter is, what is light? Is it a particle or a wave? Figuring out the answer to this question comes down to a fundamental experiment, the double slits. A laser is shined at a dark surface. On the surface, a small red point is observed. Now, the light is shined through two narrow slits, and something different is seen. Instead of perceiving two bright spots, a long horizontal line made up of many dots is observed. What is going on here? In the late 1600s, Isaac Newton said that light was a stream of particles. But around the same time, the Dutch physicist Christian Huygens said that light was a wave. So the debate raged on until the double slit experiment was first performed by Thomas Young in the early 1800s. If light was behaving as a particle, like Newton suggested, we would perceive two dots on the surface. But if light was acting as a wave, the waves could collide and interfere with each other. This would explain why there were several dots spanning across the length of the line. These spots mark where the waves interfere. So this experiment clearly shows that light is a wave, right? Let's take a look at another experiment which shows that light is a particle. Take an object that is bright pink and shine a red laser on it. As you would expect, a small red point appears on the bright pink object. But if you shine a green laser on it, the point turns orange. The light isn't changing colors here. Instead, it is showing that light is made up of subatomic particles. A particle of light is called a photon, and a photon's energy is related to the wavelength of the type of light. If the light has a shorter wavelength, it will have greater energy. In the recent experiment, the red light didn't have enough energy to activate the fluorescent pink dye. Even if you add more lasers, the color will remain static, because every photon of light just doesn't carry enough energy to activate the pink dye. Instead, the red light will just grow brighter. However, green light has a shorter wavelength. Each photon carries enough energy to activate the pink fluorescent dye, which turns the green light orange. Adding more light doesn't add more fluorescence, it just makes the orange light brighter for the same reason of the red light. The light is made up of photons, and each photon carries a specific amount of energy. This video was recorded and edited by me, Malcolm McSwain, as the first part of my newest quantum physics course, presented by our YouTube channel, Thanked. Want to learn even more? Be sure to check out Khan Academy's fantastic videos on light waves and the double slit experiment at khanacademy.org/science/physics/lightwaves.